Today we are going to continue our work with radicals. Our focus today is going to be adding, subtracting, and multiplying radicals. So let's take a look at some instructions that are required for adding and subtracting. In order to add and subtract radicals, the first thing we're going to do is we're going to simplify each radical using the methods that we have already learned. In other words, we're going to simplify them using our factor trees. After we have simplified all of them, what you are now looking for are like terms. Now with radicals, when you're looking for like terms, we're looking for radicals that must have the same radical. You're going to have problems today that have multiple radicals that are different within one problem. So just remember, when we're looking for like terms, they have the same radical. They're both radical 2, or they're both radical 3, etc. So let's take a look at a couple of examples together. We're going to start breaking down our radicals using factor trees like normal. 18 is 2 and 9. 9 is 3 and 3. As always, we look for pairs. There's our pair of 3's. So outside the radical is a 3. This 2 is left inside, but don't forget we have a 7 that we need to bring down. So our answer is 21, radical 2. The second one, 50, is 2 and 25. 25 is 5 and 5. Our pairs, there is a pair of 5's, so outside of the radical is a 5. This 2 is left inside. And of course, the 2 comes down with the 5, so we have 10 square root of 2. And then if we look in the middle of our original problem, as you can see, that's a plus sign. So I'm going to bring the plus sign down. That is the old stuff. That's all the factor trees and simplifying radicals. Now we're looking for like terms. If you look at your radicals here, they both are radical 2, as you can see. Because they are both radical 2, these are considered like terms. So to combine them, we're just going to add their numbers in front. 21 plus 10 is 31, and the radical 2 tags along for the right. It's kind of like an X. It's not going to change, but it has to tag along. Let's look at the next one, a little more complicated with 3 radicals. 90 is 9 and 10. 9 is 3 and 3. 10 is 2 and 5. We're now looking for pairs. So I'm going to cross off the 3's. Outside the radical, I'm going to put the 3. Both the 2 and the 5 stay inside. And of course, I got this 2 that I'm going to bring down in front. So this radical is 6, radical 10. Let's go on to the next one. 20 is 4 and 5. 4 is 2 and 2. Our pairs, we have a pair of 2's, so outside of the radical is a 2. The 5 is left over inside, and of course this 3 comes down as well. So we have 6 square root of 5. Then we have a 40. 40 is 2 and 20. 20 is 4 and 5, and 4 is 2 and 2. Our pair of 2's, we're going to cross off. Outside of the radical is a 2. The other 2 and the 5 stay inside, and there is no number to bring down in front, so we're going to go ahead and multiply, and we get 2 square root of 10. I'm then going to look at this minus and this plus. So I need to bring down the minus and bring down the plus. There is our simplified radicals. Now we're looking for like terms. Well, we have a square root of 10 and a square root of 5 and another square root of 10. So obviously these 2 are like terms. The middle one is not. Still important, but not a like term. So let's look at the 2 we are combining. That is a positive 6 and a positive 2. That makes a positive 8, radical 10. And the other guy, the minus 6 radical 5, still in the answer, tags along. A question that's sometimes asked, does it matter whether we put the radical 10 part first or the radical 5 part first? It doesn't matter. It's whatever order you would like to write them in. So at this point, now that we're looking at example 2, please pause the video, work through example 2 on your own, start it back up when you're ready to check your answers. So let's see how you did. 24, we're going to go through these quickly. 24 is 4 and 6, 4, 2 and 2, 6 is 2 and 3. Pair of 2's, so outside is a 2, left inside is a 2 and a 3, and the 6 comes down for an answer of 12 square root of 6. 54 is 6 and 9, 6 is 2 and 3, 9 is 3 and 3. We have a pair of 3's that gets to come outside. 2 and 3 are left inside. And the 5 also gets to come down. So we have 15 radical 6. And the other item I'm missing is my minus sign that you can see there. These are like terms. They are both radical 6's. So 12 take away 15 leaves us with negative 3 radical 6 as our final answer. Take a look at B. 63 is 9 and 7. 9 is 3 and 3. We have a pair of 3's that gets to come out front. The 7 stays underneath. The 4 comes down. So we have 12 radical 7. Next radical, we have 28. So we have 4 times 7. 4 is 2 and 2. We have a pair of 2's, cross those off. Outside the radical is a 2. The 7 is left inside. The 9 has to come down. So we have 18 radical 7. Our final radical is 44. That's 4 and 11. 4 is 2 and 2. We have a pair of 2's, cross those off. Outside the radical is a 2. The 11 stays inside. The 2 in front comes down. So we have 4 radical 11. Then we have a minus first and a plus second, so bring those down, subtract and add. So now we're looking for the like terms. These first two both have radical 7's, and that means they are like terms. So 12 take away 18 leaves us with negative 6 radical 7, and then the positive 4 radical 11 just has to tag along for the ride because he did not have somebody to combine with. So hopefully you got both of those correct, not too difficult. Let's take a look at our next operation. Now we're focusing on multiplication. These, we're going to go through some steps. First, you're going to distribute, which we've distributed several times in this class. That's going to get rid of your parentheses. Then basically it becomes an addition and subtraction problem. All of your radicals, you need to now simplify. And then after you've simplified all of your radicals, any like terms, you need to combine again. So let's take a look at two examples together. These are both multiplication. The first one, we're going to do some distributing. So I'm going to distribute these two. So the square root of 2 times the square root of 2. When you are multiplying radicals, you multiply outsides with outsides and insides with insides. That's the only things you're allowed to mix together. So these are both insides, so that's the square root of 4. Square root of 2 times 3, that's an inside and an outside. They cannot be mixed, so we just keep the 3 outside and the 2 inside. We go to the bottom. 8 times radical 2, same thing. The 8 stays outside, the 2 stays inside. And then finally we have 8 times 3, and that's 24. So now we're going to look at simplifying some of these radicals. Let's start with radical 4, because it's a nice easy one. If you are going through these problems and you know you have a perfect square, which in this case 4 is a perfect square, you don't have to make a factor tree. If you know what the square root of 4 is, you could just write that answer down. And hopefully we all know that the square root of 4 is 2. We look at our next two. Our next two are both radical 2's. You can't simplify radical 2. That radical is as small as it goes. So these are not going to change at all. And of course the 24 isn't going to change because it's already a whole number. So the only radical that we needed to simplify was the radical 4. Now we're just looking for like terms. Well, I see two whole numbers. Those are easy to combine. 2 plus 24 makes 26. I also see two radicals that are both the same. Those are like terms because they both have radical 2's. 3 plus 8 is a positive 11 radical 2. And that problem is done. So let's take a look at maybe one that's a little bit more difficult. So, as I said, you're mixing outsides with outsides and insides with insides. So the only thing outside is a 3, but inside 2 times 6 is 12. Over here, same thing. We have a 3 and a negative outside, so we have negative 3 outside, but on the insides, 2 times 2 is 4. So now let's take a look at some possible factor trees. We have 12 here. 12 we know is 4 times 3, and 4 is 2 times 2. We're looking for pairs. Cross off those two 2's. So outside the radical is a 2, inside the radical is the leftover 3, and this other 3 also stays outside. So 3 times 2 is 6 radical 3. Now the second one, again, if you're smart, you look and say, well, wait a minute, the square root of 4 is a perfect square. I'm not going to make a tree. I'm going to keep the negative 3, and I know that the square root of 4 is 2, so I'm just going to multiply that by 2. And negative 3 times 2 is negative 6. If we look at what we have there, we have one that is a radical and one that is not a radical. So neither of those are like terms. I'm going to go ahead and put a box around my answer as I see it. So hopefully those weren't too difficult. We're comfortable with distributing, and you guys should be pretty good right now with factor trees. So turn to example 4, and please try this set on your own. Pause the video, start it back up when you're ready to check your answers. Okay, so let's see how you did. Remember, outsides with outsides, insides with insides. 5 times 2 is 10. And under the radical, 3 times 15 is 45. The only thing outside is a positive 5, but 3 times 8 is 24 under the radical. So now we're ready to make some factor trees. 45 is, of course, 9 and 5, 9, 3 and 3. We're looking for pairs. There's our pair of 3's. So outside the radical is a 3. Still inside the radical is that 5. And of course this 10 comes down as well. So we have 30 radical 5 when we multiply. Let's look at the other radical, 24. 24 is, of course, 6 times 4. 6 is 2 times 3. 4 is 2 times 2. We're looking for pairs. Well, I see a pair of 2's right there. I'm going to cross those off. Outside the radical is a 2. The other 2 and the other 3 both stay inside. And we still have this 5 to bring down as well. So multiplying, I get 10 square root of 6. This plus sign here in the middle gets brought down. When you look at that, we do have two radicals, but one is radical 5 and one is radical 6. Those are not like terms, so you are done, and you can put a box around that answer. Hopefully you got that first one right. Take a look at the next one together. Remember, outsides with outsides, insides with insides. So 2 times 3 is 6, and 5 times 5 makes a 25 inside. 2 times negative 7 is negative 14, and 5 times 6 makes a 30 inside. 3 times 3 is a positive 9, and 6 times 5 makes a 30 on the inside. And finally, 3 times negative 7 is negative 21, and 6 times 6 is a 36 on the inside. So let's start looking at our radicals. Let's start with radical 25. We know, again, use some shortcuts. 25 is a perfect square. So I'm going to keep the 6 times the square root of 25 is 5. The radical is gone. So we get a 30 for the first radical. The second radical, we do need to make a tree. 30 is 3 times 10, and 10 is 2 times 5. Well, I'm looking for pairs. Here's the problem. We have a 3, a 2, and a 5. We don't have any pairs. So nothing gets to come outside. So under the radical is still the 3, the 2, and the 5. In front of the radical is still the 14. So we have 14 radical 30 that stays exactly like that. Now, we just learned that 30 isn't going to change, which means the second one is also going to stay 9 square root of 30. I'm going to bring down my plus sign with the 9, and I forgot over here. I'm going to bring down the minus sign with my 14. Now this last one, 36, hopefully you're smart and you know that 36 is again a perfect square. So I'm going to keep the negative 21 times the square root of 36 is 6. The radical is gone. So let's move that up. A line. Let's move that up here. Negative 21 times 6. So negative 21 times 6 is negative 126. So now we're looking for that final step of like terms. Well, I see two whole numbers. 30 minus 126, don't forget the minus, is a negative 96. And both of those radicals are both 30s. So these are like terms. Negative 14 plus 9 is negative 5, radical 30, and that is your final answer. So hopefully today's stuff was kind of building on old things. Yes, we were new to talk about combining like terms. Yes, we needed to talk about distributing, but the factor trees should have been the old stuff. So at this point, you're more than welcome to get started on your homework. You will have time in class to work on it tomorrow, about 30 minutes. So keep that in mind if you want to make sure you get it done in time.